I'm Simon Phillips. I'm the director of the research complex at Harwell, located on the Harwell site at the heart of the UK's leading cluster of national facilities, such as the Diamond synchrotron light source, the ICIS neutron facility, the central laser facility, and the medical research council mammalian genetics facilities. We have no departmental boundaries, and researchers from all different fields can work together. And we know that many advances in science come at the boundaries between disciplines rather than within those disciplines themselves. The only research groups here are those who have won competitive grant funding. This means as long as they can win funding for their proposals, they can stay in the laboratory. As soon as they lose funding, then they have to make way for somebody else and leave. This means that the research complex at Harwell always has the top 10% of researchers in the UK.
I'm David Clark and I run the Lasers for Science facility, which is based here in the research complex at Harwell. We're part of the Central Laser Facility, which is a national facility in the UK providing access to lasers for scientific researchers from across the country and beyond. The development of the laser has been very important for biological research in a number of areas, and in particular microscopy field. The characteristics of lasers have really revolutionised imaging of biological systems using light and resulted in the development of a whole range of different techniques for biological imaging. We're using our lasers to look at dynamics and to do imaging. That goes very well with the sort of structural information which we can get from X-rays using diamond and also from neutrons on ICIS. So there's a very complementary range of techniques and facilities here on the site.
Laser technology is very beneficial to me because it enables single molecule tracking microscopy and super resolution microscopy, which I use extensively in my work. It's very beneficial to me that the research complex is a very interdisciplinary environment, and also the Harwell campus as a whole. I don't know of any other facility that has such a great mix of different specialities and has such a great mix of facilities, experienced facility managers, users, students, a whole range of people that it's very different from being in a university.
My name is Ray Owens. I'm the head of the Oxford Protein Production Facility. Being based in the research complex has been key to the success of our project in terms of proximity to expertise for protein characterization. So we have access to facilities such as analytical centrifugation, which we can use to investigate the form of the proteins we're making. And then more clearly, next to Diamond and ICIS, where we have facilities to investigate structure in fine detail, this has all aided our ability to go from the gene sequences we start with right the way through to the protein structural. So one of the key roles we see is in training the next generation of scientists in the methods that we've developed here in the OPPF and more broadly in the research complex. And so we host visits from postdocs and PhD students throughout the year to give them an experience of the sort of facilities we have here in the research complex.
My name is Martin Walsh. I'm Deputy to the Director of Life Sciences at Diamond Light Source. I'm a structural biologist by training, so Diamond's really a critical part of the research that I need to do, so we're looking at protein structures. So my group is based in the research complex at Harwell. We do all our protein production, purification there, and then we bring all our samples to Diamond, where we can use this beamline behind me to actually analyze the protein crystals that we've actually grown and produced at RCaH. Then we can use Diamond to look at the structure of these particular proteins and aid our understanding of how they work, and also be able to try and validate them as potential drug targets to aid in drug discovery.
My name is Ian Robinson. I'm a professor of physics at University College. I also have an appointment with the research complex, and that supports my research in the structure of chromosomes, which we do using this equipment here, which is part of the Diamond light source. The methods that I developed, which were surface X-ray diffraction and coherent X-ray diffraction, are now being copied by many people all over the world, but they came about because of these close interactions that you have in a place such as the research complex. These are model chromosomes that have been printed with a three-dimensional printing technique, and in fact we're learning new things about a 100-year-old problem just because we do have three-dimensional data available. What the model shows us is that the three-dimensional shape is actually much more involved and more complex than simple views of the two-dimensional shape that you would get with traditional methods. The three-dimensional shapes are something which we get by using methods such as the coherent X-ray diffraction method that is performed here.
My name is David Scott. I'm a researcher at the University of Nottingham, but I also spend 2 days a week down here at the research complex at Harwell, where I'm sponsored by the neutron source to be here. We are years ahead in our project area because of the facilities at the research complex and the expertise here. To give you an example, we wanted 7 proteins made, and that's the sort of thing that would take a PhD or a postdoc significant amounts of time to do, months to years, and I had a PhD student do it in 2 weeks here.
In only 5 years since it opened in 2010, the research complex at Harwell has grown into a major UK centre for multidisciplinary research, with the construction of new national centres for electron microscopy and NMR spectroscopy. This site will have a unique set of facilities unrivaled anywhere in the world. And the research complex at Harwell is already full, so we are planning an extension to accommodate more researchers from different fields who will come here in the future. A key aspect of our expansion plans is to integrate collaborative work with industrial companies who can turn innovative research from the research complex into practical applications in medicine, engineering and industrial processes.